Hello, it's Mrs. Allison. Today we are going to work on the ideas of interval notation and inequalities. Now you might be asking yourself, we've already done inequalities, and the answer is yes, we have. So the inequalities that we're going to look at, we're going to add a few more steps in than we did last chapter, but really the concepts are the same. What we're going to add now is this idea of interval notation and how that works with our inequalities. So first, what is interval notation? Interval notation is really just another way to express the answer to an inequality. Okay, so the idea of interval notation and how it's different than what we've already done is that it uses parentheses and brackets to show where the graph starts and ends. Okay, so what does that look like? What does that look like when we look at something in interval notation? So let's begin with the symbols. I said it's going to use either parentheses or brackets. Well, the parentheses, what they mean is they mean that the value is not included. Well, what do we remember about things that were not included when we dealt with inequalities before? Hopefully we remember that if something was not included, it meant that it had an open dot. Okay, so our parentheses are equivalent to an open dot or used when we have an open dot. Okay, so if a graph starts or ends on an open dot, that's when we use parentheses. Now, there's one key thing. We will always use parentheses with infinity. And that's true for either positive or negative infinity, but if we have infinity in our answer, then our interval notation will always have parentheses. Great. So hopefully you think, okay, what could brackets mean? Well, if parentheses mean it's not included, then brackets mean that the value is included. Or something that is included is closed. So this we are going to use when a graph starts or ends on a closed dot. So if we see a closed dot in our picture, then our interval notation has a bracket. Okay, so let's look at what that looks like using an inequality like we've solved before. Example 1 says we're going to solve graph and write the solution to each inequality in interval notation. So we know to solve inequalities, we're going to treat it just like an equation. And when I treat this like an equation, I'm going to go ahead and think about there being a line here. And what I do on the left-hand side, I've got to do to the right-hand side. And before I begin, I notice there's a distribution. So I'm going to start by distributing my 4 into both terms. And we get 4x plus 12 is greater than 24. And I'm going to continue to solve. So to solve using inverse operations, I'm going to subtract 12. And we get 4x is greater than 12. And then I'm going to divide by 4. And we get x is greater than 3. Okay, so x is greater than 3. What does that look like on a number line? Well, I'm going to go ahead and label my number line. I'm just going to stick 3 here in the middle. What sort of dot do I have if I have a greater than sign? So it says x is greater than 3. What sort of dot do? I do an open dot. So I'm going to put an open dot at 3. And then which way do I shade my line, or where does my line go? Well, we know it says x is greater than 3. So an example of a number that's greater than 3 would be like 4 or 5 or 6. So I know my line or my arrow goes in this direction. Okay, so what we have so far is this right here. This happens to be what we call our inequality notation. This is what we've done in the past. What I want to do now is look at how that relates to interval notation. Interval notation is going to start with our lowest number first and then our highest number. So I'm going to start and I'm going to scan my number line and I'm going to look for my lowest number. Well, my lowest number is 3. So I'm going to start by putting a 3. That was supposed to be a 3. Now, because there was an open dot, I'm going to put a parenthesis by the 3. This parenthesis right here tells me that we had an open dot at 3. Then we put a comma, and then I'm going to put my highest number. Well, my highest number has this arrow that just keeps going. So is there any number that I have to stop at when we say x is greater than 3? And the answer is no, it just keeps going. It keeps going forever and ever and ever and ever. And so we call this infinity because I can start at 3 and I can go as high as I would like. Now, I'm going to put a parenthesis here, and the reason there's a parenthesis here is because we always use parentheses with infinity. Always. Okay. Now, a couple things you should notice. What you should notice about this order of the interval notation is this is where we start and this is where we end. And you'll notice it goes from low to high. That's important because we're going to look at another one here in just a moment. So if you're feeling ambitious and you would like to try example 2 all on your own, go for it. Try example 2, hit pause, try example 2, and then come back. All right, example 2. This looks a little bit messier of an inequality. I see that my left-hand side has a bit more work that needs to be done before I can actually solve this. What I also notice is that on this left-hand side, I've got a number that needs distributed, but I need to distribute the -3 before I do any work. So let's go ahead and do that. We get x. -3 times x is -3x. -3 times +2 is -6 is greater than or equal to 4. Okay, well, I see that I still have a bit of a mess on the left-hand side. So what I'm going to do is I'm going to combine all my like terms. Well, I see I have an x and a -3x. So I'm going to go ahead and combine those. That gives me -2x minus 6 is greater than or equal to 4. Now I'm going to keep solving by using my inverse operations. So I'm going to add 6 to both sides. And we get -2x is greater than or equal to 10. And I'm going to divide by -2. So x is, what's the one thing I need to remember about dividing by a negative? Remember, I said by a negative here, and that's important because when we divide by a negative, I need to remember to flip my inequality. We divided by that negative. So I would have x is less than or equal to -5 is how I would read this. So this expression right here represents my inequality notation. X is less than or equal to -5. That's my inequality notation. So let's look at what that looks like on our number line. All right, well, I'm going to put -5, -4, -3, -2. I'm just going to build my number line with -5 in the middle. Now, what kind of dot am I going to put at -5? When we've read this in the past, what have we done to put a dot for -5? Well, because it says it's less than or equal to, I know that I'm going to put a closed dot at -5. Now, which way am I shading? If it's less than or equal to -5, I need to shade towards the more negative numbers, -6, -7, -8. Again, these are algebra questions, so you could check your work if you needed to. Okay, so now let's start our inequality notation. This one's a little bit tricky because what is the lowest number I could possibly get for this? Because I know my parentheses have to have two numbers, and the lowest one should be the lowest number I could possibly get. Well, if you're thinking about this and saying, okay, well, I can keep going negative, further and further and further, you are correct. And the way we express that is with a negative infinity. And since it's an infinity, we always use a parenthesis. And that's the very first number I could get, or the lowest number I could get, is negative infinity. Then the highest number that I can get is -5. But because -5 has a closed dot, I'm going to have a bracket. So I have a bracket around -5 and a parenthesis around negative infinity. And it goes from lowest number I can get, to the highest number I can get. All right, here's your chance. With your seat partners, I would like for you to try example 3 and example 4. So hit pause and then come back and try example 3 and example 4 with me. All right, hopefully you had a chance to try these two equations that we're going to work on. Let's start with this example 3. I notice that I have variables on both sides, which means I need to get all my variables to one side. And remember, I said I like to keep my x's positive. So I'm going to continue to do that whether it's an inequality or not. So I'm going to go ahead and subtract 2x from both sides. Then what I'm left with, I cannot forget to bring down the negative. We don't want to lose that negative sign that's right here. I need to make sure that that comes down. So I get -1 is less than or equal to 3x plus 20. I'm going to move the 20 over to the other side. And we get -21 is less than or equal to 3x. And now I'm going to divide by 3. Now you'll notice I said I'm dividing by 3. Yes, the answer will end up being negative, but I'm dividing by a positive number. And we get -7 is less than or equal to x. Now that's kind of a weird way to write it. We're used to writing the x on the left-hand side. So I can reorder this simply by switching the x and the number. But what I have to remember to do is to keep the inequality sign facing the correct term. So for example, on this one, I see that the point of the inequality is facing the -7. That has to stay the same way. And then the mouth has to open to the x. So when I read this, maybe in a way we're more used to reading it, we would say that x is greater than or equal to -7. All right, how'd you do? So I'm going to put these numbers on my number line. Okay, so what kind of dot do I have here and why? Hopefully you answered that we have a closed dot, and the reason we have a closed dot is because it's equal to. So I have a closed dot because it's equal to, so I'm going to graph a closed dot at -7. And then it says x is greater than or equal to -7. So numbers that I know are greater than or equal to -7 would go this way. And in my interval notation, my lowest possible number that I can get is -7. And the fact that there's a bracket, a closed dot, means that there has to be a bracket. And then the highest number that I could possibly get is infinity. And infinity always has parentheses. So again, Remember, when you look at this, this will be my lowest possible value, lowest possible, and this will be my highest possible value that answers the question. And then this is a closed bracket because it's a closed dot, means a bracket. And remember that this parenthesis, we know infinity is always parentheses. Always parentheses. I'm just going to use the symbol. Now, what we haven't done so far is really looked at how to check our work. What does it look like if we were to check our work with one of these? Well, we can check our work just the same way we always have by picking a number that shows that it's in the solution region. So maybe we'd pick -5. And I would plug in -5 into my equation. So 2 times -5 minus 1 is less than or equal to 5 times -5 plus 20. And now I'm just going to check it. So we get -10 minus 1, which is -11. Hopefully is less than or equal to. This would be -25 plus 20. So -5. So is it true that -11 is less than or equal to -5? And yes, that isn't a true statement. So I know I've done this correctly. I know I've shaded in the correct region because both sides of my inequality are true. How'd we do? All right. If you did not do well on example 3, why don't you hit pause and with your C partner try example 4 and then come back and see how it works out. Okay, hopefully you had a chance to try example 4. Now, there is one tricky thing here. This is still an inequality. There's still variables on both sides, but it's a little bit messier on this left-hand side. We know that when solving multi-step equations, that one of the first things I should do is distribute, if it's necessary. Well, this happens to be an example where it is necessary. But what's tricky about it is the number that I'm actually distributing is the -1, and then 1's not going to be written there. So what I'm distributing is my -1 to both sides. So I'm going to leave my 3 alone. That's going to give me -2x plus 7. And I don't have any distributing on the right-hand side, so I'm just going to leave it. And now on the left-hand side, I'm going to combine any like terms. So I have a +3 and a +7. When I combine those two, I get 10 minus 2x is less than or equal to 34 minus 6x. Now remember, I like to keep my x's positive, so I'm going to move those first. I'm going to do that by adding 6x to both sides. So we get 10 plus 4x is less than or equal to 34. And now I'm going to keep solving using inverse operations. I'm going to subtract 10. And we get 4x is less than or equal to 24. And I'm going to divide by 4. Don't have to flip my inequality sign. I didn't divide by a negative. And so we get x is less than or equal to 6. Okay, so there's my inequality notation. And now I'm going to put 6 on my number line and I'm going to get ready to graph. Will I have an open or a closed dot and why? Hopefully you said we're going to have a closed dot and it's because it's equal to. Because we have an equal to, I'm going to have a closed dot at 6. And then which way am I shading? Which way am I shading if it says x is less than or equal to 6? Meaning what numbers work in that? Hopefully you said 5 or 4 or -27. These are all examples of numbers that are less than 6. So this is what your graph should look like. Now, if we want to put it in inequality notation, what is the lowest number that I can get to down here? You'll notice it's -infinity. And we always use parentheses with -infinity. And then the highest number that I can possibly get to on this is 6. And I'm going to put a bracket because I need to include 6. 6 has a closed dot, therefore it's going to have a bracket. How'd we do? Hopefully you did pretty well. Now there's a couple patterns I want you to notice. Do you notice on these problems that we've worked on that we have an infinity every time? We're only looking at things that are moving in one direction. They start at a number and move on forever. If you really want to explore what happens when maybe that isn't the case, look up compound inequalities. That's the idea that we could get to where we would have more of a defined interval. So all of these have a positive or negative infinity in them. And so that means every one of these intervals on this page has a parenthesis in it. Now some have 2 parentheses and some have a parenthesis and a bracket. And it all depends on what our inequality sign is. So if it's equal to, it's got that bracket. And if it's not, it doesn't. It has a parenthesis. All right, so you have an assignment that you can work on with this. And if you feel like you want to revisit this, go ahead and rewind this or watch some of the other tutorial videos that are posted in Canvas, just so you can see these concepts. If you're feeling good with everything, I hope you have a great day, and we'll see you soon.